What if you could X-ray Earth below our feet and make a three-dimensional model of it? That is what our next team wants to do. Please welcome Team Myonit and Panu Jalas.
Good evening, ladies and gentlemen. We are Team Myonit. The Myonit word comes from muon particles. We are a multidisciplinary team of physicists, geologists, and engineers. Indeed, we wish to X-ray the crust of the Earth by the latest particle physics and detector technologies. And an immediate application that came into our mind is that water has a different density from rock or dry rock. So if we probe deep enough, we should be able to find lots of hidden water resources in the Earth. Now, we knew this is a big problem. At the moment, it is estimated that more than 1 billion people live in water-scarce regions. That's a lot. But what we didn't know is that it's going to get much worse. The climate change, increase of population would yield that by 2025, there could be as much as 3 billion people affected by water scarcity. So this would be roughly, 30 to 40% of all mankind. So this is quite scary. There are solutions, though. Now, here is a bit technical slide. I apologize, I'm a technical guy. I have to do technical slides. This is my nature. But it is to sort of demonstrate that there is plenty of groundwater. And in fact, 97% of the world's freshwater resources are groundwater, not lakes, not rivers. Of course, there is a lot of freshwater in the ice caps in Antarctica and Greenland, but it's very difficult to access. Groundwater, there is plentiful in hidden places everywhere, if only we knew where. Now, the traditional techniques looking at groundwater are born of airborne gravimetry. This is a very fine technique that you can walk with a measurement device like this. And if the density caused by water reservoir or something else is different, you can detect the slight change of the gravity factor of Earth. And you can make a map like that, but it's really difficult to interpret it. Is it water, or is it cavities, or is it some sort of a geological formation? Now, what you can do is you can probe holes. This is what is done practically in surveying the soil layers and even rock layers, is that you bore a hole, and this hole can be up to 500 meters, even up to 1 kilometer deep. But unfortunately, it gives you only information about one specific location. And it has been shown that there is no sort of correlation between the geological or geochemical composition of the rock to the fact if there is actually groundwater or not. So we propose to use cosmic ray particles. Cosmic rays are ubiquitous. They come from space, usually from things like supernovas or some distant radiation sources. When they come to atmosphere, they become muon particles. And these muon particles penetrate into the Earth, even down to 1 kilometer depth. This is pretty amazing. So what we can do is we can use these rays in the same way as we use X-rays to sort of transilluminate, take a graph, 3D tomographic graph of the density variations on what's above our sensors. So we can drill these holes down to 200, 300, 500, even down to 1 kilometer depth and find out the hidden groundwater reservoirs that we couldn't access the knowledge in other means. So this what means we X-ray the Earth's crust, and it's a great tool to get fast, rapid information about water reservoirs that are still there, but we don't know about. Now, this is of course great. We are a team of technical people, so we would like to have water management experts, people who know about groundwater more, how to use groundwater, to support us where to go for look. Not all groundwater reservoirs are renewable, so we have to focus on the ones that are renewable. Second thing where we need help as a research team, an engineering team, is that probably most have heard that you can actually have some predatory uses of this kind of technologies. So you could go find some groundwater reservoirs that are connected to some other reservoirs and make commercial use of it without not benefiting the whole society. So we need policymakers to help us to keep water accessible to all. So this is sort of our final plea. This technology is just emerging. The detectors are there. The borehole technology is there. We just need to make a big-scale effort in making it into good use and try to get rid of the water scarcity problem that we are facing to become all the time worse and worse. Thank you very much.